All right, and here we go. So today we're going to be talking about flip-flops, and in particular, we're going to be talking about the RS flip-flop first. There's four kinds of flip-flops, but the one that's kind of most common, at least where you first talk about it, is the RS flip-flop because it's the easiest one to understand. The most common to use is a different one. It's called a JK flip-flop, and we'll get to that later, but let's talk about the RS flip-flop first. I've often wondered why these devices that are made out of logic gates were called flip-flops. And I kind of looked it up, and basically it just says it flips back and forth between 1 and 0. I don't really know if that's a good, reason for it to be called flip-flop. That flipping of 0 to 1 as a memory element is remembering either a 1 or a 0 is controlled with two inputs. And that's really the R and the S. So the R stands for reset, in which you're basically saying with the R, you turn it on and then the output goes to 0. So you're resetting it back to 0. And the S input is a set and it basically turns it to 1. So that's the fundamental part of it. The way that you make an RS flip-flop is you take a logic gate that you're already familiar with, which is a NOR gate. And like we talked a little bit about last time, you have this feedback where you feed back the output of one into the input of the other, and you do the same thing over here. Here's our two inputs, set and reset, and our output is Q. And this one turns out to be always opposite of what this one is over here. So we just call it Q prime because it's always opposite of that. All right, so the things we're going to be doing in class today are these four things with this logic gate, and then I'll give you like a one-page homework assignment. That'll probably be what it's going to be like. In past semesters, what I would do is I'd give out a 4-page homework assignment, and then I'd kind of give you a week for that. And we do every other one. But here I'm just basically giving you like a 1-page and then a 1-page. And then like today, for example, I'll do 1 page and then let you do the other one. All right, so hopefully you have a little bit of experience with multisim already. And I'm just gonna rebuild the circuit that you built for lab just so we can stress the behavior of this RS flip-flop. So let me go over here and get back over to the web. Right back over here, I'm gonna minimize that. All right, so here's the circuit elements that you need to make an RS flip-flop. And as y'all probably have already done here, or at least need to do before Wednesday, is you fed the output of this one into this one, you feed the output of this one in over here. Remember that you can kind of move the wires over in multisim. And you're gonna be monitoring the outputs, and we'll see if we can figure out which one of these outputs is Q or Q prime based on whether, which one lights up. So for LEDs, you would have a source to ground so that when current flows through there, the LED will come on, obviously. And then our two inputs, so I guess I could label them. I'm gonna guess at what they are. I really don't know which one's which, but I'm gonna double click on this one. I think that's what y'all told me, right? No, I think it's just a single click, right? All right, and we'll just call this one R just because it's called an RS flip-flop, and then we'll assign what value of Q is to the other one. All right, so there's my S. And so when we turn this thing on, there's the power button for our Heathkit experimenter. By the way, I don't know why that one's blinking now. That's kind of odd. Okay, that has never happened to me before. I was gonna show you that thing, but it's got a lot of chips on it, never mind. All right, so let me turn one of these on and see if it stops. Okay, it did do that. So I think it was basically floating around, and because of the delays in the gates, it was just oscillating back and forth like we saw in the NOT gate back on Wednesday, 5 days ago. All right, so this one right here, basically I've said to reset it, and there they go. I'm gonna label this one right here Q. Let's see if I can do that. I think you have to turn the circuit off in order to do that. All right, I'm gonna use a lowercase q for that one. I found on these that you really can't label it what you want to, which is, I wanna label it Q prime, but it doesn't like that. So I'm just gonna put a Q underscore. For some reason, it accepts that. So there I've reset it, this output over here to 0. I'm gonna turn the circuit back on. And so basically when you have R and S equal to 0, here's the main point. If you have R and S equal to 0, it says, remember what happened last time. whatever happened last time, I want you to just, display that. And whatever it was last time was Q is equal to 0, so it's going to stay that way. If I click this, it's going to set this on. And then if I go back down, they're both 0 again, but it remembered that I turned set on previously. That was the last thing I turned on. So here's reset and set. And that's basically what a flip-flop is basically saying, I had got 1 bit of memory. And if I imagine having 1,000,000 of those, I have a gigabit of memory. If I have 8 million of those, I have a megabyte of memory. Okay, so that's how you make memory, is you have a bunch of these microscopically, and you just make lots and lots of them. You don't have to use NOR gates. I think you can use other gates as well, as we'll see with the other flip-flops. Well, yeah, you can use other gates as well for this. All right, so getting over to the in-class assignment, and I'm going to do a little bit of lecture here and a little bit of things to get together here, first of all. And then I'm going to kind of turn you loose on the homework. So here's the flip-flop in diagram form. If we turn it this way, you see basically that's the circuit I built just a minute ago over there in Multisim. So what we want to do, first of all, and remember I had 4 things I wanted to do with this. One of them is to create a truth table, create a Carnell map, write a next state equation, and then have a next state diagram. Those are the 4 things I'm trying to accomplish. So if I build this on a circuit board, I would basically take the output of this one and I would feed it in right over there. Okay, so here is basically the truth table, where here is S and R, and this is what the value of Q was last time. The last time I toggled those inputs. And does anybody remember what Q star means? It's different than Q prime. And let me turn on the chat window in case anybody can answer that one. So what does Q star mean? Anybody that's done a little bit of the homework or the lab from last time? Probably the homework.
Next state.
The next state. So in other words, it's basically talking about the future. So Q is talking about, I guess, now, the present state, and here is what's going to happen next. Now what we could do is say that anytime we turn the set on right here, anytime we set it, this should be 1 right here and 1 right there. I think so. Is that right? Yeah. Okay. So anytime you set it, it's going to be like that right there. Now the other thing is we can say that, let's see, if we have reset on, which is right there and right there, what number should I put here? It's here. It's obviously going to be 0 and 0. Okay, so if I put that in, that means reset. And this right here means set right there. And that should be center justified. Oh, what a tragedy. Okay. Not like it matters, but I'm going to do it anyway. And it didn't do a thing, did it? All right, so I'm going to select that center. There we go. Okay. Now, does anybody remember how we should handle the case where S and R are down? What did that mean when S and R are just 0? I'm neither setting nor resetting. And you can type it in the chat if you want to.
Does it stay in the current state?
Right. It remembers what you had last time. It stays at the current state. So here's the current state. So if it was 0 here, then it's going to be 0 over here. And if it's 1 at the current state, it's just going to remain that. That's the basic element of memory. That's 1 bit of memory. And when you get down to these last 2 things right here, so this basically, if I were to put a parentheses right here, and I normally do that on the board, I say this means remember, this means reset, this means set, and you're not allowed to do this last thing. And you could maybe see why, because you're trying to set and reset at the same time. And logically speaking, you shouldn't allow you to do that. So we're going to say, I don't really care what the output Q is for this, because I don't want to set and reset at the same time. That's, a contradictory, logical statement. All right, now I try to make a Carnell map out of a Excel worksheet, and I think I did a pretty good job. Well, it wasn't Excel, it was, Google Sheets. All right, let's see if we can figure this out, and then we'll come up with the, here's our output Q, and we're trying to come up with the Q star equation from this Carnell map. Okay, what goes there? I guess a 0. And then do I go to the right or down? I forget how I do this. Let's see. So this right here is, so I guess the order is I go here, here, there, 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 and there. Does that sound right?
Yeah, that looks right.
Okay, so 0, 1, and then I go basically, let's see, 0, 0 here, and then I put a 1, 1 right there, and then an X and an X right there. And I couldn't really figure out how to draw things, although, no, I couldn't really figure out how to draw things over here. So I'm going to see if Zoom can help me out with that part.
Yeah, we can annotate on it.
You know what? Let's, who wants to annotate? I see, Ely, do you have a, I see your mic is on. Do you have, are you on a PC where you can draw on the screen?
Yeah, I'm. My hand's gonna be a little shaky though.
That's all right. We can erase it if it gets all over the place. But basically, see if you can solve the Carnot maps, and I'll write out the equation here.
Okay.
What circles should we sketch on this Carnot map?
This is what I get, and then
Good.
you go across.
Man, you probably did that better than I could have. Did you did it with your finger, not a stylus? That's pretty good. All right, so somebody else on the in the room here, tell me what the equation is going to be for Q star. I didn't really mean to do that. Sorry. Oh gosh, messed up your circles. I guess it's because I hit enter like that. There we go. Okay. All right, so what is the equation going to look like right here? Anybody else in the room? Let's see. And you can type that in the chat if you want to.
So with that top bar, would it be, for the little cube, would it be Q or S? Because I don't.
Are you talking about this right here?
Because the box.
The box, okay. So for the box, Q changes. Okay, so this is Q along this axis.
Oh, okay.
Yeah, it's the only way I can figure out how to do it. I'm really supposed to have a diagonal line there, right? You know, but I couldn't figure out how to make that happen. All right, so then that means Q changes.
So is that just going to be S?
Oh, it's going to be S then. Very good. Okay, and then we're going to say or whatever the other thing is.
Q.
And that's going to be Q.
Q.
And
S.
S.
Right?
Yeah.
I thought it was going to be R prime.
Oh, yeah, because the 0 is not
wrap around. There's 0 here and 0 there.
Oh, right.
Okay. So this is what's called the next state equation. So normally we have just a static thing and there's like a different letter here like Z. But now we're saying on the next cycle, what's going to happen is that it's going to depend on this equation, the values of R and S and what Q was previously, just moments before changing the value of R or S. All right, so that's basically it right there. Let's see, how do I do the clear all drawings? Okay, got it. All right, now, great, now I have another drawing coming up there. All right, so the way we symbolically draw this flip-flop circuit is with a box. And so here's what it looks like. Additionally, what we can do is add another step in here so that we're kind of incrementally looking at time. Instead of just waiting for R and S to change, which you could do and just leave, you know, the R and S flip-flop could just be that right there. But what you could also do is say, let's check moments in time periodically, like once a second, once a millisecond, once a microsecond, you know, and really get up to those gigahertz clock rates. And that's where this middle thing comes in right here. That's where you put the clock in at E. It's basically saying, how fast am I going to make that decision about the set and reset? And so here is our extra wire right here. The clock is E, and here's R and S a little bit backwards over here on the block diagram. And then the output's Q and Q prime. So in this chapter, they symbolically, well, actually in electrical engineering, the standard is to take those 4 gates and then draw them as a box. We might get into what this means right here, but it basically means I'm only going to change on the when the clock goes from positive to negative. This means trigger on the negative edge is what it's called. So instead of changing when the clock goes up to 5 volts, it's going to only process information on the way down, trigger on the negative edge. We may or may not get to that part. We'll mostly be focusing on this next state equation right here. You can take this next state equation and then make a next state diagram, and I think it's down here. but let me get to that in just a second. Sorry for zooming around so much. All right, so I mentioned at the beginning of class today that there are 4 kinds of flip-flops. The RS flip-flop, and here's the next state equation we just derived from the K-maps. The D flip-flop has a different collection of logic gates in there. We won't worry about what's inside. We'll just say it's a D flip-flop, meaning delay. And here's the next state equation for it. It has only 1 input. And basically, it's like 1 clock cycle behind. That's why it's called the delay. And the toggle has a different next state equation. And it basically, when you have this on right there, it toggles back and forth between 1 and 0 for every clock cycle. If you have it off, it remembers where it was when you turned it off. So on, it toggles back and forth. The Q value is back and forth. If you put T equals 0, then it stops where you ended up, as stated by this equation here. And the most common kind of flip-flops is the JK flip-flop. And it has 2 inputs similar to the RNS flip-flop, and it has an exclusive OR right there. We'll probably be using that one in lab on Wednesday. Okay, any questions so far before I get to the next state diagrams?
Is it important for us to remember the diagram on the right?
No.
Or, no, all right.
That's a good question. I'm glad you said that. Remember when we first started the semester, I said on the inside cover of your textbook, there's these theorems that I'm going to give you during the test in the same way. Since we're past mid-semester. If you look on the inside cover of your book, you'll see that it has all the flip-flops, all 4 flip-flops there. And so that's what I do on the test is I give you an equation sheet, which basically has the next state equations, the next state diagrams. And you all probably know how it works. It's more about knowing how to do it than memorizing things. So that's kind of the way I operate is you get familiarity about how to use the tools and not have to memorize it. After a while, you begin to memorize them. But we're not going to have to do that for a test. Good question, Austin. All right, so here are the next state diagrams. These require just a little bit of explanation. They're kind of similar to what we did for homework last week on Wednesday. Very similar to that. Let's focus on the RS flip-flop. So they just kind of put the label in the middle right here, just to remind you what kind of flip-flop it is in this chapter 6 that we're in. And on the inside of the circles, in every one of these cases, is the value of Q. So Q is flipping back and forth between 0 and 1. Flip-flop, 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 flip-flop. Okay, so that's the value of Q on the inside of the circle. So the outputs are inside the circle. These outputs right here, Q, 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 inside the circles. All right, and just like in Wednesday's class, when we talked about the arrows indicate what the value of the input is. So for the D flip-flop, there's only 1 input. So for the D flip-flop, if you turn on 1 clock cycle later, it'll go from 0 to 1, and it'll just get stuck there as long as you leave the input D equal to 1. As soon as you make it 0, it goes, all right, I'm going to go over here 1 clock cycle later, and I'm just going to stay there. And if you go back to 1, it goes over here like that. That's how that one behaves. And you can see how the S and R work, just like we talked about before, but there's 2 values, not just a single input. There's 2 inputs, and that's S and R. So if S is equal to 1, it goes, come over here and stay with the output 1. If it says reset and set, it means, come back over here and reset. Wait. What? I guess, yeah, they labeled that incorrectly, right? No, let's see. Set goes over here. Oh, yeah, I'm sorry. Okay, reset. That is labeled correctly. So you reset it back over to here. And you see 0, 0 right here means remember. And 0, 0 over here just means remember. And you see no cases where both R and S are equal to 1. Okay, so in every case, you have 2 arrows leaving the circles here and there. Just like in the T flip-flop, if you leave the T input equal to 1, it goes flip, flop, flip, flop. And then eventually, if you let T equal 0, it goes stop, and I remember where where I was at when you stopped. And then you turn it back on, flip, flop, and then you say, once you're over in this state right here, you turn the T to 0, and he goes, I'm going to remember that. And J and K is very similar to this one, except you have the 1, 1 corresponding to basically toggling back and forth. So it's like a combination of these two gives you a JK flip-flop. Here's a summary. So this is what you can use for your homework as far as the next state equations. And finally, before we get into our in-class exercise, I want to talk about the two kinds of sequential networks that count or look for patterns. I just noticed somebody has a diode for their screenshot. Let's see. There's two kinds of sequential systems, and one of them is called Mealy, and that means the output Z out of that network is going to only depend upon, well, it's not going to, the word only shouldn't apply there. It's going to depend upon the current state, which normally means Q, and the input, which normally means X. So the Z output will depend upon Q and X. The difference here is that more models, and we're going to identify different kinds of circuits as we analyze them and determine whether they're Mealy or more. A more is only dependent upon Q, has no dependence on X, the input X. And in a previous course, some students in that class developed a mnemonic for that, and they says if it's a more model, then it depends upon less. Basically, it doesn't depend upon the input X. You'll see what I'm talking about in a minute as we look at a real circuit, and now we're there. So here is homework number 8. We're going to do page 1 together in class today, and we got about 35 minutes to do that in, and I think there'll be plenty of time. And then maybe we can even, as a class, start on the page 2. But really, it's problem 1 and 2. If you want to expand these to take up more than one page, you can certainly do that. All right, just so everybody can see what I'm talking about here. Make sure everybody is with me right here in the chat. Get ready to type or get ready to turn your microphone on. Remember, I'm going to have some really softball questions here. How many flip-flops do I have in my network in figure 6.22? And you can type it in the chat or say it out loud.
2.
2. And then what kind of flip-flops are they? Just making sure y'all are here with me.
One's a D,
Right.
and then
Yeah, the
I'm
other
gonna take a guess for both they're the same.
MRD. So usually you can tell by all what's drawn on the inside what they are there. Okay, I meant for this to be on the next line over here. Let's see if we can get this back over this way. There we go. All right, it looks like I had already worked on it a little bit yesterday, and I really meant for us to do this live. So I'll just see if I can work this out with you. You'll see that on the problem number 2, what I'm asking for is what is the output Z? What are the inputs into the A flip-flop and the B flip-flop? And then basically answer some other questions like state diagram and state table. Remember that the title of this chapter right here is Analysis of Sequential Networks. All right, so we have 2D flip-flops. We have an input X over here, and the clock is just ticking away, let's say once a second, processing information that comes in on X. And we're also doing some logic here, where the logic gates are basically looking at X, but it also has some feedback out of the first delay flip-flop. It's got a little bit of feedback out of the second delay flip-flop. And so we want to figure out, what is this circuit doing? When you're in industry, you might encounter something like this. You have a circuit and you want to analyze what it does so that either you can troubleshoot it or you can re-engineer it. Okay, so hopefully you can see that the way we figure out what Z is, and in that problem, by the way, it basically says find Z, find the value of D1, which is this flip-flop here, and D2, which is that one right there, in terms of Q1 and Q2 for the circuit shown here on that page. Okay, so I've already done this last night. I forgot I did that last night, but I'll explain what I was doing. The output Z is directly connected to Q2 prime, so that's what I write down right here. Now, This might give you all some more experience with, writing equations, which is a good skill to have either for your future classes or for your future job. So whether you're in Microsoft Word or in Google, you can write equations. And the way that I wrote this equation right here is I basically went into this and I said, insert equation. And I'll do that, as we get down to these other problems. I'll show you how to insert equations so that you can put the squares and the primes on there. All right, so the next one is identifying that this right here is really D1 because you can see Q1 and Q1 prime listed right there. And we say, what is the input into D? Because that's one of the goals we had, was find these three things. We've already found Z because it's directly connected to that. Analyze the circuit, write the equation. Analyzing the circuit D1, it's the plus sign right there between these two things. And one of them is X and Q1 prime. And there it is, X and Q1 prime. The other and, if I follow these back over here, is Q2 prime. And then the other one, if I go back over, let's see, this one right here is Q1. So there's Q1 and Q2 prime. And finally, we look at the value of D, 2, and it's basically anding two things together, Q1 and also the input X. All right, so I did that for you already, and that's a similar process you're going to do for the homework for the other circuit. Just carefully analyze them. You can refer back to this video to help you if you need to. All right, now I want everybody to get ready to type into the chat, and you're going to write either Mealy or more, okay? So we're not going to say it out loud. We'll just say Mealy, or get ready to type Mealy or more. Based on what you know about this circuit right here, I'm highlighting Z. And based upon the definition you see right here, is this a Mealy circuit or a Moore circuit? Okay, let's see if I can get both of them on the screen. Well, I can't really. Let's see. All right, so there it is. Z is equal to Q2 prime. Is it a Mealy or Moore? All right, so type that in and then hit enter. I guess I should run a poll or something like that in Zoom, but we don't have to take that much time with it. And I'm seeing there in the chat, everybody is saying that that is a Moore circuit. And it's Moore, I mean, how can you identify if it was a Mealy? I mean, what would be here if it was a Mealy? Anybody can say that out loud or in the chat?
If it needs the X there, probably.
The X, right? I just noticed Dean pointed out that it's actually right. It's right there. Sorry. Okay, so it's a Moore circuit. Thank you. Okay. Great. Thanks, Dean. That's good. It actually says it in the circuit. Okay, I wonder if the other one does as well. Okay, it doesn't say it on the other one, so you have to figure that on your own. Okay, thanks. All right, now what we want to do next is write the next state equation for this particular circuit, and we want to do it in terms of just Q1 and Q2. We might have to have X in there too, I'm not sure. I guess we'll find out. All right, so we realize that these two things are D flip-flops. So we scroll all the way back until we find the fundamental equation for a D flip-flop. And the fundamental equation for a D flip-flop says right here, a D flip-flop is that the next state is just equal to whatever the input was. That one input coming into right here. So on the next clock cycle, it's going to be one clock cycle late, but it will be there. All right, so let me just focus on this one more time. Q star is equal to D. That means that down here, I need to say that this right here is D, but not just D, because I have two flip-flops there. So what do I need to do instead? Not just D, and I've deleted my equation accidentally. Let me get inside the equation right there. Say equals D, and then I need to put a subscript on there. And let's see if I can pull that down. Let's see. It should really have like a equation already there. So where are my tools for the equation? Usually they're right down here. allowing me to do a subscript. I guess what I'll do is just copy and paste it like that, I suppose. That didn't really do it. All right, well, let me reload and see if it will let me do it in that case. So if I just up here, for example, say insert equation. All right, there's my equation toolbar right there.
If you just use an underscore, it'll automatically do a subscript.
Really?
Yeah, inside of the equation editor.
Good job. Wow, I did not know that it would do that. So
Yeah, it's the same in Microsoft Word too.
good job. All right, so you go like this, underscore.
Yeah,
Wow, that's such a time saver.
yeah,
you.
it is.
All right, so then I type in D and then underscore 1. And then I guess you have to do caret if you got something else, right?
Yeah, yes, sir.
Okay, well, it made a caret of the subscript, but that's okay. All right,
If
then
you
down
use
here,
your arrow to move away from
oh
it,
yeah,
it should
go away
stop.
and then come back in there.
Yeah.
Good job. All right, so then we go D right here, underscore 2 for that one right there. Now, if I keep typing like this, that's not going to, create the equation here like we want to. So I need to go over 1 using my arrows on the keyboard here, and then say equals. The thing is, I already know what the value of D1 and D2 are up here. So I'm just going to copy and paste them just like that right there. And I'm coming right here like that, there. Okay, equals this. So now I know what the value of Q1 is in terms of Q1, Q2, and I guess I should really say and X. And there it goes again with that thing. Okay, so it does have a dependency, at least the Q1 and Q2. Now the Z doesn't have any dependency on X. Q1 and Q2 do have some dependency there. And so I can take this right here. And this is an easy one because, the delay flip-flops are really easy to analyze, which is why I started off with that anyway. Because you look at these other ones up here and you see that you got to feed in the value of S and the R, and it gets a little more complicated. So I started with the easy one where it's just like, just write it and you're good. Okay. And there we go. All right, so now we finished part C of the problem. We've done part A, B, and C. Now we're going to use those 2 equations right there to complete the next state table. All right, I probably need to get it so that you can see both this right here and the state table right there. Okay, I got both of them in there. And there we go. So I need to use this equation, or these 2 equations, to figure out what these things are over here. Now, I guess an easy one might be to figure out what the Z is. And Z was something that we had figured out previously. So I might go and grab that right here, copy that down here, and say, just paste it to remind myself that I know what the value of Z is. Okay, so I have a little technical difficulties here. All right, so can anybody tell me what 4 numbers I put right here based on the top Z equation? We're analyzing that circuit and creating a next state or a state table. All right, so if anybody wants to type into the chat 4 numbers, yeah, let's do it that way. So everybody kind of get your fingers on the keyboard there, type in 4 numbers for the value of Z. All right. And so basically what you're chatting or writing in the chat there is that you basically take the opposite of what Q2 is. Here's the value of Q2. And you said opposite, 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 opposite. All right, now becomes the difficulty, and that is figuring out what Q1 and Q2 are on the next cycle over here. So basically there's going to be, on either side of this underscore, I'm just writing this to remind ourselves that there's got to be a value for Q2, Q2 star and Q1 star, like it has to be a number here and here, just like I have this right here. You might remember last Wednesday that in these present state column, I had add letters, A, B, C, and D. But you can also have numbers which correspond to numbers 1, 2, 3, 0, 1, 2, 3. So you could use letters, but in this case, we're using combinations of ones and zeros. All right, so I like looking at Q2 first of all. You don't have to do these underscores. I'm just putting them there so that you know which one I'm about to do. I'm going to do the Q2 first. The reason I'm going to do Q2 first is it's easier. All right, so what should I put in those 4 numbers right there? And I'm looking at Q2 star if X is equal to 0. All right, get ready to type those into the chat. Hopefully it's pretty easy. When X is equal to 0, what is Q2 star? Q2 star. When X is equal to 0, what is Q2 star? Those 4 numbers for Q2 star. All right, anybody want to type those into the chat? Y'all got it. Very good. 0, 0, 0, 0. So if X is equal to 0, that's going to force Q2 star to be that. Since that's a simpler equation, let's stick with it. What if X is equal to 1? What are those values going to be right there? All right, get ready to type in the chat and tell me what those 4 values are right there. All right, you basically say, well, if that's 1, then I just need to be focusing on what Q1 is. And Q1 is not the answer there. Okay, there you go. Now you got it. Good job. So 0, 0, 0, no, 0, 0, 1, 1, because it's got to match up with this is right here. All right, so now I've finished with Q2. I picked the easier one. Now I'm going to go to this side, and then I'm going to get rid of those underscores, you know, the spaces that are in between the two. All right, so if X is equal to 0, then that term right there doesn't matter. So I'm looking at these 4 numbers right here. So it's getting a little more difficult as we move along here. But we're getting, you know, close to the end of this chart here. So if X is equal to 0, then that term basically goes away because or 0 is just, you know, anything or 0 is just the anything. So now I want you to focus on those 2 things right there. Q1 and Q2 prime. My question is, what are the 4 numbers now? All right, somebody's already typed something in. I don't know if I agree with that one, Luke, but that was a good guess. Changed his mind. Okay. So we basically need to look for the case. Okay. Sorry. We need to look for the case where Q1 is equal to 1 and Q2 is equal to 0. Boom, boom. So basically it's that right there, and the other cases are 0. And if this doesn't, that kind of looks like a sad face there. Anyway, sorry. Easily distracted. All right, so there's our next state if X is equal to 0. Okay. Basically, we're looking at that condition where this is equal to 1 and that's equal to 0. I know this is probably pretty complicated, so don't worry too much about it. Come back and watch the video again if you get stuck. And of course, I got my office hours as well. All right, let's try this last one, and then we'll go on to the state diagram, and which hopefully will be easier, and we'll be done. All right, so 10 minutes left. I bet we can do that. So if X is equal to 1, then I got to look for the case where this is 1, which is that guy right there, or I got to figure out when Q1 is equal to 0. And Q1 is equal to 0 right there and right there. So the other condition right there is 0. This is the most difficult one, and hopefully you understand why I saved it until the end. I'll say it one more time. If X is equal to 1, I'm going to keep that term, but I need to turn it on for the cases of Q1 being equal to 0. And I also need to turn it on for the case of Q1 equal to 1 and Q2 equal to 0. All right, and there it is. Now, what we need to do is our final step for this in-class exercise, which is going to be, you know, the same steps you're going to use for your homework, for that circuit, it's a different circuit, turn vertical, is we need to do the zeros with the ones and the arrows and stuff like that. So I have a drawing over here, and so I'm going to go grab that. I think what I got to do is I got to make a copy of it so that I can reuse this template over and over again. So I'm just going to copy this template and then say something like, I don't know, homework 8 or something like that. All right, hopefully I grabbed the right one. This one does appear to be a more circuit. So I think I did grab the right one. And instead of A, B, C, and D, the template really should have had a D there. It really needs to have, 0, 0, 0, 1, 1, 0, and 1, 1. Now, what I should probably do is see if I can expand this out. I wonder how you make these bigger. I guess what you can do is go to page setup, give it a little more space up here.
Getting ready for work.
I'm sorry, say that again.
And I'll be downstairs for the rest.
I think somebody else is talking there. Okay, so I wish I had more space there. I guess what I'll do just momentarily until I figure this out is I'll just make a new drawing. That way I have plenty of space, and I'll just grab these circles. Control A and Control B right there. And there's my diagram that I want to work on. The reason why I wanted to do that is because I want to be able to show you all this table right here while we're making the state diagram. So I'm going to copy this, and hopefully let me put it right here where we can all work on it. Then I can kind of zoom in on a little bit closer, and let's see if we can figure this out. All right. So what numbers should I put below the horizontal line? And I'm talking about this number, this one, and that one. Anybody want to turn their mic on for that one? Let's see.
Just 1, 0, 1.
Would it be 1, 0, 1, 0 in the order that you?
I think you're right. Yeah, 1, 0, 1, 0, because you can see that column is right there. So very good. So I need to go 1, 0, 1, 0. This is going to time out just right. We got 6 minutes to finish up the arrows here. I'm going to go back over like that. So now we start asking those questions. If I'm on, and by the way, you can print this out and do it by pencil, do it with pencil if this is too tedious to try to do all this stuff. It's just easier for me to show you in this way instead of getting the pencil on paper. If I'm on state 0, where do I go next if x is equal to 0?
You loop around.
Loop around. So I'm going to go like this, and like that, and then like this. Right, and then what if x is equal to 1?
Go to 1, 0.
1, 0. So in that case, it looks like I can just go straight down. So go from there down to there. And I can straighten it up. Go over like this. And that's x equals to 1. All right, now we go on to this one. And we are on this guy right here. And you can probably see that what we're going to do is we're going to come, if we start on this one, we go back to home if x is equal to 0. So back home if x is equal to 0. And it looks like we're going to loop back on ourselves if x is equal to 1. Is that correct?
No, it goes to 1, 0.
Oh, good. Thanks. All right, so go here. Got the stylish wiggle like that. Yeah, I saw some of the homework y'all were doing. It looks really good the way that it turned out. So keep up the good work there. All right, and we got 4 more to go and 4 more minutes. So we can do this. All right, so we got 0 and that arrow. I'm gonna copy it and save it because now I'm right here. And I gotta, systematically do this. I need to loop back onto myself here. So go like that, and like this, and like that. And I'm so glad the dogs weren't too bad. All right, and so basically you can see that I went from here over to there, and when I landed there, wait, oh yeah, when I landed there, it was 0. Okay, so that's what that is right there. All right, 2 more arrows to go. Let's get the 0 arrow, first of all, like that. Where do I go if x is equal to 0 and I start on 3?
0,
It's like
0.
you go to 0, 0.
Go back to 0, 0. I suppose that what we could try is go like this and like that, but it might look a little confusing. I think some of you are doing things like this. Maybe we could do that. Can you, wait, go up? Yeah, there may be no clean way of doing this within the application. Okay, I pulled it off. The other thing I could do is just move this one in, right? So if these stay connected, I think that's the nice thing about this application is that if you're on pencil and paper, you have to erase, but here it looks like you can drag and drop and these connectors stay in place. So 0, I'll go back to there, and then it looks like if it's 1, not too bad. Right here, as far as organization of the arrows, I just go right over to there. I think I'm only doing that so I can fit the 1 in there. All right, as a double check at the end, you want to make sure that you have 8 arrows. 1, 2, 3, 4, 5, 6, 1, 2, 3, 4, 5, 6, 7, 8. All right. So you want to make sure that you always have 2 trains leaving the station, so to speak, 1 for x equals 0 and 1 for x equal 1. As you can imagine, these get more complicated as you move forward. You can have not only an x, but an x and a y input. So it's almost like going from a simple Carnell map to a bigger one and then going in 3 dimensions. But as you also can imagine, you start to use a computer to solve these bigger, more complex problems. When you have state tables, which have a lot more variables involved. We will always stick to having just 2 variables for this one, because that's where the fundamental understanding is needed in order to design bigger networks. All right, any questions over this right here? What you will do is take this right here, and then you can say Control C, and you come down over here, and you put Control V. Oh, that's terrible. Okay, so that didn't work.
You try and screenshot.
The screenshot.
You can do a snippet of it.
All right, so I'm going to go down to my windows. You won't see this part on your screen, but I'm going to type in my snipping tool, come back over to this one right here, make it look like that. I guess I can paint the background white. Oh, there it is. Okay, go like that. So that way it makes a cleaner cut. Grab the snipping tools. We're having to use all kinds of technology for this class, right? Grab that right there. I don't know if you saw any of what I just did, but there's my result right there. And I can kind of take all of that, and there's my answer. So that's what I want you to do for the next problem, is just go through these steps. Come up with this equation, identify the type of network, come up with those equations, state table, state diagram, and that's all I really wanted you to grasp there for this one. All right, any questions then? I'll stop recording right here, and then we can stick around if we have any informal conversations y'all want to have. Let me stop recording right